Every day, we enjoy convenience and comfort. The future is a constant surprise. But bigger tech means bigger energy needs. Our development and even survival hang in the balance. We at Huawei accept this mission. We unite power electronics with IoT, big data, and AI. Our breakthroughs in green energy make generating and using it efficient. We cut costs for getting power and use it to grow communications and boost data center potential. Mankind steps into the future with a greener footprint. Our pursuit of a fully connected, intelligent world relies on a rock-solid energy supply. Our energy solutions safeguard connectivity and computing and drive our transformation into a new era. Our goal of a leaner, smarter O&M evolves us to full automation. When ICT infrastructure can be self-learned and O&M self-driven, we open new roads to digital transformation. Energy. It empowers our continued survival against all odds. We use bits manage watts to make 0 watts for 0 bits a reality. Redefine the future with energy. Persevere in our march forward. Huawei is committed every step of the way. Every day, we enjoy convenience and comfort. The future is a constant surprise. But bigger tech means bigger energy needs. Our development and even survival hang in the balance. We at Huawei accept this mission. We unite power electronics with IoT, big data, and AI. Our breakthroughs in green energy make generating and using it efficient. We cut costs for getting power and use it to grow communications and boost data center potential. Mankind steps into the future with a greener footprint. Our pursuit of a fully connected, intelligent world relies on a rock-solid energy supply. Our energy solutions safeguard connectivity and computing and drive our transformation into a new era. Our goal of a leaner, smarter O&M evolves us to full automation. When ICT infrastructure can be self-learned and O&M self-driven, we open new roads to digital transformation. Energy. It empowers our continued survival against all odds. We use bits manage watts to make 0 watts for 0 bits a reality. Redefine the future with energy. Persevere in our march forward. Huawei is committed every step of the way. Every day, we enjoy convenience and comfort. The future is a constant surprise. But bigger tech means bigger energy needs. Our development and even survival hang in the balance. We at Huawei accept this mission. We unite power electronics with IoT, big data, and AI. Our breakthroughs in green energy make generating and using it efficient. We cut costs for getting power and use it to grow communications and boost data center potential. Mankind steps into the future with a greener footprint. Our pursuit of a fully connected, intelligent world relies on a rock-solid energy supply. Our energy solutions safeguard connectivity and computing and drive our transformation into a new era. Our goal of a leaner, smarter O&M evolves us to full automation. When ICT infrastructure can be self-learned and O&M self-driven, we open new roads to digital transformation. Energy. It empowers our continued survival against all odds. We use bits manage watts to make 0 watts for 0 bits a reality. Redefine the future with energy. Persevere in our march forward. Huawei is committed every step of the way.
On our planet of civilization, humans have stepped into the intelligent era. Ubiquitous connectivity, pervasive intelligence, technology builds a better world. Our efforts to build a green world never cease. Renewable energy has become a main energy source, accessible to every person, home and organization.
Welcome, ladies and gentlemen, good afternoon, and welcome to 2020 Huawei APAC Smart PV for Future Virtual Summit. I'm so delighted and honored to be here. I'm Gorawin Siriaksan. We're going to be your host for this summit. And today, we are going to discuss about the topic of how Smart PV is leading the future of solar. In recent years, Smart Solar continues to deliver extraordinary new features, which include AI and numerous key technologies that mark the innovative frontier in this industry, to deliver an intelligent and sustainable future. We are really excited for this unique opportunity to have leading solar industry experts to share their industry insight and trend with us today. And throughout this event, we have got special giveaway along the way. So please stay tuned with us. But first of all, ladies and gentlemen, I would like to take this great opportunity to invite the president of Huawei Smart PV, Mr. Chen Guoguang, to officiate today's summit. So once again, join me in welcoming Mr. Chen.
Dear friends, welcome to Huawei APAC Smart PV for Future Virtual Summit. Unfortunately, we can't meet in person due to COVID-19, but I hope all of you and your loved ones are staying safe and sound. Today, we are delighted to meet you here through this virtual summit, and together discuss future trends in the PV market with solar industry experts, exchange valuable insight and experience in this vibrant Asia-Pacific region. First, I would like to share Huawei Corporation semi-annual financial data with you. Despite the challenging time globally, Huawei's revenue increased by 30.1% year-on-year. Also, Huawei's FusionSolar, according to IHS and Wood Mackenzie's report, Huawei ranks #1 for the 5th consecutive year in all of the regions and key countries, including Europe, APAC, Middle East, Latin America, India, and Japan. This proves the value we create together for customers. The total shipment of Huawei FusionSolar Smart PV solution is 130 GW until June of 2020. For half-year shipment of APAC, we increased by 55%. We can't achieve such achievement without our customer and partner support. And on behalf of Huawei's team, I would like to say thank you to all of you sincerely. As to our industry, the technology innovation have exceeded expectations in recent years. Utility-level solar power plants are even more competitive than traditional energy sources in most of the regions. Middle East just broke the record and lowered the price of solar power to $1.3 per kilowatt-hour. In Latin America, the rate went down to $1.8 per kilowatt-hour. PPA projects are gaining traction in France and Germany as well. And China will also add another 10 GW project free of subsidy this year. The LCOE will continuously decline as all the component costs fall further. How do we stay more competitive in this market? Since 2013, we have been the pioneer to introduce string inverter into large-scale solar plant, along with many smart features like multi-MPPT, power line communication, smart IV curve diagnosis, and smart DC systems. Now, working with more than 3,000 people in digital power R&D team around the world, including Germany, Spain, Japan, and China, we will continue to invest in our international research center and co-innovate with our customers to ensure even lower LCOE, stronger grid support capability, higher safety level, and better experience. In the future, AI will be as ubiquitous as water as electricity. It is a strategic technology that will lead the future, and it is a new core engine that will drive PV industry transformation towards intelligentization and create more value. 2020 will witness the comprehensive integration of cloud, AI, and 5G technologies. As such, we have further integrated AI to enhance the intelligence of our smart PV solution. We can't wait to share more details with you today. Let's work together for our mutual success and bring the Smart PV for Future vision into reality. I'm looking forward to meeting with you soon. Enjoy the event. Thank you.
Thank you, Mr. Chen. 2020 has been challenging as we adapt to the new norm of global pandemic. To discuss with the global PV market and changing trend of the industry, we have with us today Mr. Sam Wilkinson, Director of Clean Technology and Renewable of IHS Markit. So please join me in welcoming Mr. Wilkinson.
Hi everyone, my name's Sam Wilkinson and I'm delighted to have been invited by Huawei today to share with you some of the latest views from IHS Markit on how COVID-19 is impacting the solar industry. Now 2020 has been a year unlike any other. And the word unprecedented has been used a lot. But I was trying to think if there was any similar things that had ever happened that could, possibly be compared to this. And for some reason, it got me thinking about a very famous scene in the movie Jurassic Park, which I remember very clearly from when I was a kid. And there's a scientist explaining the idea of chaos theory, or the butterfly effect. The idea that a butterfly flapping its wings in one place could change the weather entirely in another place thousands of miles away. Now, who would have thought that just over half a year ago, an outbreak of a virus could actually change the course of history all over the world? So there's been a huge amount of disruption. And I'd like to just share with you some numbers that actually illustrate the level of disruption we're talking about. Just to start with, there is now 18 million confirmed cases of the virus, and that has increased from just 1 million in April. So a huge increase and a rapid acceleration around the world. IHS market experts are now forecasting a global decline in GDP of over 6%. That is a huge change to the 2% growth that we saw in 2019. Travel around the world has changed beyond belief. And this number here illustrates that. A 74% drop in commercial flights if we look at April 2020 versus April 2019. But we're not here to talk about these global indicators. We're here to talk about the solar industry. So let's just think a little bit about what has happened in the solar world. First of all, the first impacts of this virus were felt in China. And as China started to shut down in order to try and slow the spread of the virus and control the virus, we saw a major impact on the supply of solar components. Over 70% of polysilicon, wafer, cell and module manufacturing is based in China. So it is easy to see why, with such strong restrictions on logistics and work, that people started to be very concerned about their ability to actually procure all of the components that they required to build projects all over the world. But the situation changed very, very quickly overnight. China was able to control the spread of the virus domestically and began to ease restrictions quite quickly. Production came back. Logistics were able to cope with the increasing demand and actually start to move products around again. But elsewhere in the world, the virus had begun to spread, and very quickly demand from the rest of the world collapsed. As restrictions were placed on how people could move about, where people could work, it was very, very difficult for the solar industry to continue as it had done. So we saw a threat to the production very quickly turn to a collapse on the demand side. What we're starting to see now as restrictions are eased in most places around the world is that momentum is actually starting to build again. And there is great optimism about demand for technologies like solar in the future as part of this potentially green recovery. Now, it is true that the pandemic has impacted different sectors in different ways. The ground mount sector in some cases has actually been able to continue almost unaffected. In countries like the US, for example, the market has continued very, very strongly. In other regions, construction of large ground mount projects was halted for a month, maybe two, because people were unable to go to work and it wasn't deemed essential work. The rooftop segment obviously suffered from very similar things. Very, very difficult for people to go and visit people in their homes, visit businesses in order to construct projects or to build plants or to discuss the details. But actually one of the more important things for the rooftop segment will be the economic impact of this pandemic. We're all very aware that this is going to have huge economic repercussions, and so businesses and individuals like you, like I, will potentially be very, very careful with the amount of capital that they're willing to spend. So if I sum up all of that for 2020, IHS Markit is now for the first time actually predicting that global solar demand will decrease in 2020. There is across the board big reductions made to the forecasts for the reasons that I've just discussed, but there's also some slight variations to the trend as well. Actually, the biggest of those variations comes from China. We actually increased our forecast for demand in China when we first made our changes to the forecast in April. The reason we did that was that we were confident and we expected that there would be some policy intervention to help the domestic manufacturers of China and to actually help to stimulate additional demand. In the rest of Asia, we have made some quite large cuts to markets as those restrictions continue to reduce the amount of demand, reduce the amount of installation activity that can happen. For example, we've made quite a significant cut to the Indian market as those restrictions are in place and as international trade becomes more and more challenging. The other big exception was in the USA, where, as I mentioned earlier, we've seen the market continue in a very resilient way. We already predicted very strong growth for the US market ahead of the changes to the ITC, a very policy-driven situation. And we've seen the worker there continue to go, projects continuing to be built. But let's think a little bit more about some of the longer term, bigger picture impacts here, rather than talking about the specific change to megawatts installed in 2020. And there's 4 key themes here that I've picked out. The first one is the big question that we always get asked. With oil prices so low, how can solar compete? And what I would say is that actually what this is doing is highlighting one of the biggest values that solar can offer. Solar, once it's built, has very, very low, very stable, very predictable operational costs. It doesn't rely upon a supply of fuel that can increase in price or decrease in price. It can also see disruption to that supply with the potential for not being able to actually secure enough fuel potentially. So solar can offer something in these times of price volatility. Yes, oil prices have gone down. Oil prices will one day go up. That is certain. So I think that it really does highlight one of the key benefits that solar can offer. Another thing, and I'd like to just talk for a few minutes about this, is that it has also really highlighted some of the digital technologies that has allowed solar to become such an advanced technology that offers low-cost power. So, it's very important when we're here today talking about Huawei technology that we acknowledge that through digital technologies we are able to offer situations and solutions where O&M can actually be carried out from remote locations. Faults can be diagnosed from very, very far away, and we're minimizing the amount of times that people have to visit a plant to actually carry out maintenance. That's probably a reason why string inverters have actually been able to become such a major part of our global industry. And in 2019, string inverters accounted for over half of global shipments, and in the utility scale sector accounted for nearly 40% of shipments. And that's also been a major part of how Huawei has become the largest supplier of PV inverters globally and has been for the last 5 years. This idea that digital technology can allow solar to continue to improve, continue to be a low O&M, a low OPEX solution is very, very important to the future of solar. We also see a very big trend towards what is being called deglobalization. People are increasingly concerned about ensuring a local supply, and that includes electricity. So again, solar being a technology that once installed doesn't rely upon a continuous supply of fuel is very, very important. So the pandemic is again really highlighting some key benefits of solar technology. The last thing on a more policy focus is that we really do see the possibility that the recovery plans, the stimulus packages that will be required to allow global economies to get back on their feet after this situation, many of them will favour low carbon, clean, renewable technologies, and that may well place solar in a very, very good place for growth again in the future. So finally, to sum all of this up, we do see a big reduction to our previous forecasts for solar deployment in 2020, and the economic challenges that will follow this pandemic will also reduce demand compared to our previous forecasts in 2021. However, we predict that by 2022, solar installations will be back in line with where we had previously forecast them, and therefore we'll see continued growth, and the solar industry continues to be in a very good place with a very, very bright future. And so to conclude, there is huge short-term disruption from COVID-19. However, it really does highlight some of the really key benefits of solar. And again, the digital solutions that are being offered today to allow people to remotely monitor and remotely operate their PV plants are going to be key towards solar being a very highly valued technology in the future. We also believe that solar can play a key role in a green recovery, and we see that the fundamentals for growth remain on track, and that we do think that the market will be back to its previous growth trajectory by 2022. Now, thank you very much for listening, and I hope you enjoy the rest of the event today.
Thank you, Mr. Wilkinson, for solar market outlook and analysis under COVID-19 situation. So now on to our next agenda. Our first giveaway for the day is Huawei LED P40 Pro. So the name of every participant today will be displayed on the screen, and one of the lucky winner will be picked randomly and displayed on the screen. Congratulations, a Huawei representative will be in touch with you by email shortly to arrange the logistic of receiving your prize. We have more giveaway in the following section, so stay tuned. So up next, we will focus on hot topics today, AI. This is the forefront of technology as Huawei continues to build a fully connected, intelligent world. AI is shaping a new and exciting future for solar, contributing to advanced development in technology. To share this exciting future, please welcome Mr. Steve Cheng, CTO of Smart PV APAC Huawei, to shed light on how AI drives a fully connected smart solar plant. After his presentation, we will have easy quiz section, and 50 winner will each receiving a Huawei Band 4 as a special prize.
Good afternoon, ladies and gentlemen. Welcome to join our summit. Over the last few years, AI has become a high-frequency word, and it is enabling us to deal with new challenges, pursue better lives. For example, during the prevention and control of COVID-19 pandemic, AI is playing a vital role in facilitating wellness analysis, drug research and development, intelligent temperature measurement, as well as auxiliary diagnosis. Based on the understanding above, Huawei provides FusionSolar 6.0 Plus utility smart PV solution. Consists of 1A5 KTL smart string inverter, smart array controller for data transmission and control, smart transformer station for overseas ITS solution, and the smart PV measurement system for real-time monitoring and management. And today, I would like to introduce our latest progress, how we deploy AI technology in FusionSolar. Smart tracker control algorithm. AI trains tracker control algorithm for each PV plant with mass local data to best capture solar energy and increase energy yields. Let's have a look at the tracking scenarios. In the traditional way, the module, tracker system, and the inverter are all isolated to each other. In the tracking control, conventional atomic algorithm and backtracking algorithm only following the sun path and adjust the tracking angle, which will cause inner load shedding when the ground is uneven. And in cloud day, the track angle is not optimal to harvest the maximum energy from the modules. To improve the track control, Huawei integrates AI slow neural network and self-learning modeling by sensing the mass data like voltage, current, elevation, temperature, wind speed, and so on, from the PV plant to form a closed loop control between the tracker module and the inverter and optimal the tracker algorithm. The inverter acts like a brain of the plant. In the morning, the SDS algorithm will individually control every load to avoid inner load shedding. When cloud loss occurs, smart tracker control algorithm can sensor the elevation change and reposition tracks to harvest more energy. In the evening, the SDS will help to harvest more power by improve the control algorithm. We have tested this technology in PV plant in different latitudes all over the nation, and the results showing that compared with standard model, smart tracker control algorithm can increase the energy generation by 0.5 to 1.3%. We also use AI to reduce O&M complexity and OPEX, as well with smart IV curve diagnosis analysis. Compared with conventional solution that use on-site sampling test and time-consuming manual analysis, smart IV curve diagnosis can largely shorten the diagnosis time from weeks to half a day. AI learns expert knowledge and can accurately identify 14 types of stream failure, which is certified by TÜV. The diagnosis can further provide troubleshooting solution to close loop the O&M process. This function has been deployed in 5 GW PV plant worldwide now. Huawei continuously upgrade algorithm to shoot more and more scenarios. In this year, the first generation can support diagnosis of mono, poly, bifacial, and BIPV PV modules. It is now also compatible with mixed installation of different PV modules in one string and Y branch connections. And in this year, I'm very excited to launch this new AI algorithm on grid connections. As the LCV of the PV continuously decreased, solar is expected to become the major energy resource. According to IEA's outlook in 2019, in the near future, over 30% of the annual newly installed power plant will be solar PV plant. However, renewable energy access is now increased, and the traditional generator, like the thermal power plant in some countries, are reviewing. In addition, PV plant is usually constructed remotely, and the PV plants are generally far away from the grid. Therefore, we can find that the SCR of some regional power grid will be lower and lower, or in another way, more and more regions will face a new challenge of weak grid. The chart on the right is based on the Bloomberg's prediction of renewable energy penetration in several regions. It is expected that between 2025 and 2030, HCR will be lower than 2 in some countries here. Huawei has been research on the grid connection PV industry for many years and has invested heavily in precise insight into the power grid status and improving control accuracy. Currently, Huawei has achieved stable grid connection in all scenarios. The value of this technology to a customer is that site selection and the conditions of changing power grid is not affected. The algorithm supports stable grid connection in weak power grids with SCR down to 1.5. The improved higher voltage fault ride-through capability at the same time improves power quality by surpass current harmonic less than 1%. In the weak grid connection testing, the output waveform of Huawei inverter is still stable when the SCR is 1.5. However, the output waveforms of other string inverter is distorted when the SCR is 3, and the inverter can work only with reduced power or switch to shutdown for self-protections. In terms of power quality, in a real power grids with background harmonics, Huawei inverter ensures that the THDI is less than 1%. In comparison, other string inverter can barely achieve the claimed THDI of less than 3% in laboratory conditions. In real power grids, the harmonics would surge to 9%. Besides the test result, we know that Australia's new standard in February 2019 is the world's most stringent power grid standard. Huawei helps our customer to get the first admission to the new grid standards for a 95 megawatt PV plant in Victory. The approval time for this project is only 50% of other solutions. In China this year, Huawei Sun 2000 inverters is the first to meet the technical requirement for grid-connected inverters, which cause higher requirement on high voltage ride-through, low voltage ride-through, and also frequency adaptations. And another rare case occurred in northeastern China in April this year. A 100 megawatt central PV plant was built and the grid connected in the end of last year, and afterward, a small PV plant 20 megawatt nearby was grid connected as well, which utilized Huawei Smart PV solutions. In April this year, a grid fault of face-to-face short circuit occurred and further led to low voltage in the local grid. So what we learned from this case? For a long-term PV plant operation in daily changed grid scenarios, a smart inverter with strong grid connection algorithm become particularly important. Huawei has a very rich experience in battery storage development. By 2019, Huawei has shipped over 5 gigawatt-hour lithium batteries worldwide. In base station, data center, off-grid PV plant, and so on. We also ranked the global #1 in 5G power and the modular data center. We are now in the process of using our success in batteries to develop our own energy storage system in on-grid PV solutions. And the solution will be ready for the market in the middle of next year. Huawei ESS will be a brand new solution for the market, with our focus on reducing the LCOS of the storage system in the long term. With higher system efficiency, lower OPEX, prolonged battery life, and improved safety, Huawei ESS can reduce LCOS by more than 5%. making PV plus storage solution more cost-effective to customers. In C&I PV plant, the system size may be as large as megawatt level. The PV cables that connected to the remotest PV modules to the inverter may be as long as 200 meters. With current UL 1699B standard, the maximum arcing protection range is only 8 meters. In addition, some C&I plants utilize bifacial PV modules. The current arcing stance cannot cover either. Now with Huawei C&I enhanced arcing protection, all these will be a peace of mind. Currently, almost 100% of arcs can be identified using AI algorithm that ensure system safety by enabling quick break protection. Huawei's AI-powered active arcing protection represents the first attempt to integrate AI algorithm into arc fault circuit interpret in the industry, featuring more accurate arc detection and faster fault rectification. The solution comprehensively ensures the safety of distributed PV plant. The AI Boost AFCI offers 3 unique features. Firstly, it continuously and effectively learns arc features using AI models, and it has a library with over 1 million arc features. Secondly, based on the powerful local chip computing capability, the AI Boost AFCI proactively identify and analyze over 92 arc feature comparison points, and performing precise detection without fault reporting or under-reporting, providing comprehensively protection. Thirdly, it can shut down and cut off power supply within just 400 milliseconds, which is much faster than the industry standard of 2.5 seconds. The product enables customers to build secure rooftop PV plant. We believe that in the near future, the AI Boost AFCI performance will become the industry standard globally. As digital technology and renewable energy are reshaping the world, we firmly believe that our society will become intelligent and the next 3 decades. Powered by AI technology, the PV industry will be reconstructed and redefined, and the new world, where everything is sensory, is connected and intelligent, will become green and more vibrant. Thank you for your support.
Thank you, Mr. Steve. As mentioned, here's an opportunity for you to get your hand on our next giveaway. It's easy to participate and gives you the opportunity to win a Huawei Band 4. There are 50 Huawei bands up for grab, and here's how you can get your hand on one. The QR code is showing on the screen. Scan to access the question, and the first 50 participants to submit a correct answer will win this quick response question session giveaway. So thank you for such an overwhelming response and congratulations to all who have participated. A Huawei representative will be contacting you shortly, and please also stay tuned with us because at the end we will have 2 more of Huawei P40 Pro. So on next our agenda is a drive-in hybrid firm with AI. We have with us today Mr. Chatchai Mawong. He is Director of Hydro and Renewable Energy Power Plant Development Division of Electricity Generating Authority of Thailand. To discuss with us how generation of electricity through solar hydro and storage system can be delivered as a hybrid. So right now, please join me in welcoming Mr. Chatchai Mawong.
Hello everyone. Today my topic is driven hybrid firm with the AI integration. I will talk about my hybrid project in Thailand and show how to make it firm. At the end, I will present the future development with the AI integration. As present, Thailand Energy Direction had a trend to reduce reliance on electricity generations from fossil fuel and encourage increasing use of renewable energy. The proportion of renewable energy will increase about 30% in next 20 years. Despite being green energy, it is undeniable that there is still instability due to natural uncertainty. The smart technology is a solution to support the growth of renewable energy in the future. Electricity Generating Authority of Thailand, or EGAT, is the main utility that oversees security of electricity in the country. It must go beyond development of the renewable energy in the general, which must be stable, not affect the price of electricity. The combination of renewable energy is the technique that ICAT had adopted. ICAT will develop the last project of hydro-floating solar hybrid with energy sourced from solar power plants in conjunction with the hydro power plant. There are 16 projects using the surface area on 9 dams of ICAT across the country. It has total capacity of 2,725 megawatts. The first project will be piloted at Sirinthorn Dam, Ubon Ratchathani province with capacity of 45 megawatts. Designing energy management system, or EMS, that combine hydropower and floating solar power. EMS help to manage energy by producing electricity from solar power during the day and bringing the hydropower to support the peak demand at night to significantly reduce electricity generations from fossil fuel. In the future, hybrid power plant will create more flexibility and stability in electricity generation. It will be designed with the state-of-the-art technology, including AI, to analyze the hybrid generation in real time. It enables predicting power generation and helping energy management efficiently. The concept of development is divided into 3 phases. Short term, build flexibility of power generation, designing to combine hydropower and solar power for a hybrid system. Medium term, build security of the power generation, designed to combine hybrid system with smart technology, such as energy storage system, AI technology. Long term, create a renewable energy control center to enable energy security with AI integration. The center will manage RE power plants across the country with one platform and high accurate energy dispatch. AI integration helps to manage energy efficiently and reduce the cost of electricity generations from renewable energy. Hybrid power plant consists of hydro, solar, and battery. AI helps analyze data for planning and managing of power generation, such as energy use, energy management, and weather forecasts. RE Control Center collects big data from its hybrid power plants. AI helps analyze the data for energy management in real time with high accurate energy dispatch. The main function of RE Control Center are big data analysis, generation monitoring diagnostic, power grid optimization, energy dispatch optimization, renewable energy plan. AI integration brings a great impact on every industry. making everything more convenient, efficient, faster, and smarter. The integration of AI into our hybrid power plants is a part of our ongoing efforts to digital transformations for making better the future energy. This is how we start to reach our company vision. Innovate power solutions for better lives. Thank you for everyone.
So thank you, Mr. Chatchai Mawong, for sharing us how a hybrid firm can be achieved through AI and also to enhance stability and security of renewable energy, as well as to reduce its variability and uncertainty to power grid. And next we have Mr. Ivan Vulat, Head of Solar Section from DNVGL, to share about what is digitalization and how will it impact solar. And what should the industry expect from this change? Leading this exciting topic on digitalization in the solar PV industry. So right now, please join me once again in welcoming Mr. Woolard.
Hello, my name is Evan Woolard and I'm the head of section solar for DNVGL based in Singapore. It's my pleasure to speak to you today about digitalization in the solar power industry. When I was a kid growing up in America, I remember the power company sending a person to check our energy meter every month. A few years ago, the power company stopped sending those trucks every month to the house that I grew up in, and it had been doing for so many years as digital energy meters were rolled out by PECO, the Philadelphia Electric Company. Now you find smart meters everywhere. I will come back to the smart meter later. So now I would like to talk about what digitalization is. And to talk about that, I think we need to define some terms first. Digitalization is about making things digital. This could be moving from analog devices to actual digital hardware. The second thing is digitalization. These are the business opportunities created by the previous one on terms of making analog devices digital. And lastly, digital transformation, such as new business ideas and even new businesses that are created as a result of the digitization of certain analog devices. Now back to the smart meter example. The smart meter itself is a digitization technology, digital technology that has been transformed from analog to digital. But what business opportunities were created as a result of that? Well, the Philadelphia Electric Company didn't need to send a truck to our house anymore, enabling really large cost savings when that's extrapolated across many households in the region. And also consumers had better access to data in terms of getting that data through their smartphone, without having to even walk outside to check the electrical meter. Digital technologies are enablers of digitization. From the computers that are used, whether it's cloud computing, sensors through the Internet of Things, or new software that utilizes machine learning or artificial intelligence, all of these technologies together enable digitalization. Now I'd like to talk about DNVGL and some energy trends that we see. So as you know, DNVGL is a global risk management company. We have 5 main businesses, but I think really the key thing is, I sit in energy, but 70% of our business is related to energy, one way or the other. And what we see as a long-term energy trend is with respect to decarbonization of energy generation capacity. So right now, less than a few percentage points of the world's power generation capacity is actually renewable energy. What we see in the next 25 or 30 years is complete transition of that generation capacity to renewable energy through primarily wind and solar. This is available publicly through our Energy Transition Outlook. Another trend we see is decentralization of power generation sources and consumption of energy. On the left, you'll see the traditional way of power generation and consumption, which is unidirectional flow of power. What we see transitioning over the last few years is really bidirectional flow of power from large generators down to small consumers, but also small consumers becoming generators themselves. Now I would like to speak to you about digitalization in floating solar. DNVGL has what's called a JIP, or Joint Industry Project. This joint industry project is a kind of recommended standard for the industry to improve its quality and reliability. This is a set of requirements for safe and reliable and quality-driven approach in order to get to a safe floating solar set of standards. This will contain guidelines on many different topics in floating solar, such as mooring and anchoring, permitting, installation, O&M, and so forth. Key topics that will enable safe and reliable floating solar. This particular document is scheduled for publication in the first quarter next year and will be publicly available, freely available online. These are our JIP partners. These partners are world-renowned experts and leaders in the field of floating solar with several gigawatts of capacity either in construction or in development worldwide. DNVGL also has several applications, digital applications in floating solar. These include DNVGL's remote inspections, which enable access to our best experts worldwide using the latest technology to be able to inspect either factories or power plants remotely. DNVGL's mooring and integrity management system of mooring lines, which is an asset condition monitoring of those particular mooring lines to be able to accurately assess their performance and predictability, or how close to failure they actually are. In DNVGL's offshore and oil and gas business, we have a lot of experience in analyzing these particular mooring lines, and now we're bringing that to floating solar and the floating solar industry. Mooring and design rules. These are design standards available online to enable safe and quality mooring design lines in the oil and gas industry that are being transferred to the floating solar industry. DNVGL Solar Farmer, which is a tool that enables very fast electrical layouts to be performed for floating solar and land-based solar layouts, and within that also includes sub-module electrical modeling, and this type of modeling enables high accuracy energy yield assessments. And DNVGL's Synergy Life, which is an automated application to improve cycle time of health and safety applications. And now I'd like to talk to you about machine learning in solar asset management. DNVGL, through Green Power Monitor, or GPM, offers a SCADA and asset management solution. And this asset management solution contains plant-specific dashboards. And plant-specific dashboards obviously are very important with solar power plants because they enable proper asset management and efficiencies. What is more unique is our device-specific dashboards, which are very important when it comes down to analyzing particular issues and tying work orders to specific equipment. Many power plant owners have separate systems for performance and separate systems for work orders and O&M activities, but we see that it's really important to tie both of those together in one application in order to really get the most bang for your buck in terms of proper asset management and improved cash flow. Within that is machine learning for our inverter expected power model. Inverters really have several different inputs, and they're almost like living and breathing organisms. And many of those inputs impact how it operates, how efficiently it operates, how long it's going to operate, and ultimately the power generating right now at that particular moment. So through machine learning and a neural network, which is essentially a set of equations, we're able to accurately model or forecast the output power of each particular inverter. And that's really important because over an entire plant, there's going to be several different inverters that are going to be experiencing different inputs, different temperatures based on site location, different wind speed, and this is really going to introduce variation. So being able to model that accurately is going to be able to further predict the maintenance required for that particular machine. And that's called predictive maintenance as opposed to scheduled maintenance. So what you want to do is you actually want to be able to predict how soon that particular equipment is going to fail. And this is what DNVGL is able to do with our Green Power Monitor and SCADA asset management solution. And it should be noted that GPM has been installed worldwide across many different countries, many different brands of equipment, including Huawei. Now some conclusions. I think DNVGL, we're able to assist customers using both machine learning and AI technology on several different fronts. We're able to optimize power plants with our Solar Farmer software, which is really about reducing financing costs due to improved accuracy, improved efficiency. We're able to reduce mooring failures through standardization of mooring design guidelines. Ultimately, this is going to improve total cost of ownership for owners of power plants. And finally, asset management and energy forecasting, and through DNVGL's GPM and improving owners' IRR. Thank you very much. That concludes my presentation.
So thank you, Mr. Voulard. It's been an information-rich summit so far we have learned about. So let me summarize. Firstly, the first half-year global PV market for 2020, an emerging trend during COVID-19. Secondly, how AI drive a fully connected smart solar plant. And third, a drive-in hybrid firm with AI. And fourthly, a digitalization in the solar PV industry. For more information about our solution and other offers, please check on our website on the following on social media. And following is the video about Huawei FusionSolar Smart PV Solution Update Virtual Tour.
Welcome everyone to the FusionSolar Smart PV Virtual Tour. My name is Ethan Fu from Huawei Smart PV Business. It is my great honor to guide you through the tour today. In the virtual tour, there are 7 sections on demonstration. Section A is the FusionSolar Smart PV Solution Global Case Video. B is the Utility Smart PV Solution. C is the Commercial and Industrial Smart PV Solution. D is the Residential Smart PV Solution. E is the FusionSolar Management System Demo. F is the Green Energy, Green World part, including data center, asset power, and microgrid solution. And lastly, section G is the M-Power solution. Now, let me take you to section A first. In the FusionSolar Smart PV Solution Global Case Video, we can see several classic Smart PV cases in utility, C&I, and residential scenarios. PV systems with Huawei FusionSolar smart PV solutions are all over the world, across Blue Ocean to Golden Desert, and are in diverse environments, from freezing cold to scorching hot. In addition, key features of smart PV solution are also on demonstration. After you watch the video, let's go to the FusionSolar Utility Smart PV solution in section B. Here, we are in the Utility Solar area. Let's look at the overview for the solution first. There is a comprehensive presentation of utility solution key features. And down the bottom of the screen, we can find 3 AI Boost applications. The first block is introducing the principle and benefits of using smart DC system. The second block is smart IV curve diagnosis introduction. Lastly, smart grid connection algorithm is also explained thoroughly. Next, let's look at the Huawei Smart PV inverters. Technology has changed our life and also the way we see the world. So, with the virtual tour, we are presenting you inverters in 360-degree angles with zoom in and out views. Therefore, you can easily check out the exterior of inverters at any angle. Besides, the key features of respective inverter are also shown. Lastly, there is an introduction of Smart Transformer Station in the last screen. Now, let's go to Commercial and Industrial Smart PV Solution in section C. We start from the first screen down the C&I area. And we can see the challenges faced by current C&I PV system and Huawei C&I solution introduction. Here is the active arcing protection demonstration. Besides, features of active safety, high yields, maintenance-free, and smart IV curve diagnosis are also presented. One click on the respective feature will lead you to the detail. C&I inverters are also on display. The one you are seeing is the Sound 2000 30, 36, 40 KTL-M3 inverters just published. Next, let me take you to the residential smart PV solution in section D. Down the residential area, we can also see the challenges faced by current residential PV system and Huawei residential solution introduction. Like the C&I area, by clicking on the respective block, we can see the detailed introduction of active safety, better experience, and high yields. As you can see, residential inverters are also on the wall, and we can find the new released Sound 2000 226 KTL-L1 inverter. Next stop for us is the FusionSolar management system demo in section E. Here, we are in the FusionSolar app and Smart PV Management System 7.0 demonstration area. Here is a short video about the FusionSolar app, features of local commissioning and plant registration. Moreover, we can explore the Smart PV Management System 7.0 down here. Each function is followed by detailed explanation. Under the case part, we can learn how to check yields and historical information. Now, let's go to section F. Down here, ISAT power, data center, and microgrid solutions are introduced. Firstly, let's look at the ISAT power solution. The ISAT power is widely used in safe city, smart transportation, park monitoring, oil and gas pipeline monitoring, and other scenarios. It consists of power and network integrated modules lithium batteries, PV panels, cameras, and ROS, providing customers with a one-stop outdoor video surveillance solution. Hereafter, we can explore the data center solution. Huawei is building a simple, green, smart, and reliable next-generation data center by providing all module, all smart, and all lithium batteries solution that cover both indoor and outdoor areas, ranging from small-sized edge data center to medium and large-sized data center. Next, let's look at the microgrid solution. According to the latest data released by the International Energy Agency, there are still 114 million people with no electricity globally, who mainly reside in rural areas without traditional power grid. The Huawei microgrid solution is designed for electricity supply of these remote areas, with features of fast deployment, flexible expansion, and simple maintenance. Huawei microgrid system has been deployed to more than 400 rural villages and is benefiting more than 300,000 people around the world. In the future, Huawei will continue to contribute more to narrow the digital divide. The last stop for the tour is the mPower solution. Adhering to the deep accumulation in digital power, Huawei is committed to electrification and to taking digitalization boost a green journey as our mission to help car companies build great cars. Huawei mPower has launched an end-to-end solution with the highlights of longer range, stronger power, more safer, reliable, comfort, and multimodal adaptation. Today, it is only a brief introduction of FusionSolar Smart PV virtual tour. I just hope you have enjoyed it. For more solution and product detail, please visit FusionSolar Smart PV Solution website, solar.huawei.com. Thank you very much.
So next, we have a panel discussion on, first, how to achieve a better LCOE for solar project. Second, future technical trends and device selection. And third, AI application in solar industry. To lead this panel discussion, we have three key opinion leaders with us. So I cannot wait to hear their insight. Now, over to you.
First and foremost, thank everyone for joining us today. We really hope that today's session will be both enlightening as well as providing you with a lot of insights to the industry trends and the best practices that our panelists today have to provide and to also offer to you as our guests. So once again, thank you so much for joining us here today. Today we have a great lineup of panelists that will be able to share with us based on their experiences and their rich background in the solar PV industry. So without further ado, I'd like to introduce them to you. The first being Ms. Jen Tan, who is the Senior Vice President and Head of the Solar Department at Sembcorp Industries. And then our next speaker would be Mr. Sanjay Agarwal, who is the Managing Director of Fortum India and Global Head for Solar at Fortum. And of course, our third panelist would be Mr. Kanin, who is who oversees the business development of SunTrace for the Southeast Asia region. So once again, thank you so much. These are our panelists for today. And without further ado, I would like to address our first line of questioning to Mr. Sanjay. It is our great honor that Fortum India has just signed a 250 megawatt solar farm project with Huawei using 100% of the string solution. Could you please share a little bit of your journey with Huawei?
Thanks a lot. Thanks for inviting me to discuss about these string inverters. Clearly, our relationship with Huawei goes quite some time back. In fact, we did a detailed audit of Shenzhen manufacturing facility in April 2017, and we were impressed by the manufacturing facilities of Huawei and the quality control that was there in the Huawei factory. We were always debating whether to go in for a string inverter or for a central inverter in all the power plants that we were putting up. And finally, when we decided to put up the 250 megawatt Jaisalmer project, we were again comparing and evaluating both the string inverters and the central inverter solution. But finally, we opted for Huawei string inverters more from a perspective of that it was giving us good yield optimization. The balance of supply was also getting simplified. There was ease of construction during the construction phase and clearly during the maintenance phase as well, meaning when the power plant would be operational. There was the ease of maintenance. Clearly, along with the journey, when we were evaluating the string inverters and also during finalization, I think one of the most important element that we looked for was how good the technical support is and how quickly the response time is when we ask them a query. And we had lots of queries because we had not used string inverters before. This was for the first time, and that too on a large. It is practically a 334 DC plant and a 250 megawatt DC plant. We were doing all string inverters, so we had a lot of queries, and I think each and every time we felt, and we had to have evidence also that all our queries were responded fast. And plus, I would say our guys also wanted to learn, and there was always a need to learn more about string inverters. So it was not only the queries, but we also wanted to know what future advancements are happening in the string inverter technology. And clearly there were a number of good R&D workshops which Huawei kept on organizing, in which our technical guys sort of kept on understanding more and more. So our journey of Huawei, which started off with April 2017, when we first saw your manufacturing facility, to now in 2020, meaning nearly after 3 years, we gave Huawei the first order. So for the last 3 years, we've been discussing. So I think it's more important during the discussion phase that how quickly you are responding to our queries, even though in the last 3 years, we landed up putting a 250 megawatt plant also and a 70 megawatt plant also. And we didn't go ahead with string inverters. So I think what I'm emphasizing is that once you get the contract, obviously a relationship builds up. But before the contract is finalized, it's that time when we require you more if we have to take a decision. So I would say the support has been great. And of course, with respect to the technical performance, we were happy with what Huawei had to offer. And that's the reason we decided to go ahead with Huawei.
Wow, thank you so much. And really, we really do appreciate your feedback on this, because it is very, very important. I believe that one of the things that Huawei strives for is to provide a very holistic approach to supporting you as our customer. So thank you for that sharing. I think that's very, very insightful. My next question to you would be a little bit more broad perspective. As the global head for solar at Fortum, what would be your global forecast outlook for the solar PV industry?
I think if you would see till, if I were to, okay, I would take you back around, it's very difficult, at least for forecasting solar, because it operates typically in a geometrical fashion, geometrical progression, in a sense that it's not that you would have conventional 10% increase every year and so on and so forth. Even going by an Indian experience, and then I can go to the world experience, if I were to look back close to around 8 years, in 2012, that is 8 years back, the total installed capacity of solar in India was around 300 megawatts. And as we speak now, it's close to around 35 gigawatts. So within a space of 8 years, we've moved from 0.3 gigawatt to 35 or 37 gigawatt, meaning there has been a growth of nearly, I would say, more than 100x. And in the same time, if you were to forget about the units that I'm using, the solar tariffs have gone down from 18.5 rupees per kilowatt hour to 2.5 rupees per kilowatt hour. So in 8 years time frame, the market has moved more than 100x. I would say the tariff has come down, let's say around 8x on the lower side, which I would say that if we both would have been in 2012 discussing like we've been discussing, we would never come to a conclusion that from 8 years now, this would be the market. Nevertheless, so what I'm saying is that clearly this is a disruptive technology, and in disruptive technologies, uh, the the tipping point when it comes, nobody knows, but you need to be always in that technological phase. Uh, in 2019, as I've been told, that the total capacity, installed capacity, the total, I would say, global solar market was around 117 gigawatt peak, out of which around 12 gigawatt peak was installed in India. This year, because of COVID situation, I think it would be less. But I would presume that from next year onwards, it would again follow a trajectory. Clearly, we feel that there would be essentially uh, 5 countries where maximum solar would get installed, which will be China, USA, India, Japan, and Germany. And typically, India would remain around on number 3 on these markets. But I would presume that this market would grow anything between 20 to 40% every year as we move forward. So if the market was around 117 uh, gigawatt last year, I would presume that by 2023, it would clearly move up to 180 gigawatts per year, and moving up to close to around 200 gigawatts by 2024. So starting off from 117 gigawatts in 2019, practically the whole market would get doubled up every year by 2024. So by 2024, I expect this 117 to become 200 gigawatts every year, with these five countries occupying the 1, 2, 3, 4, 5 sort of levels. The second level can move to first level. I would say India would be somewhere on the third in these stacking up of 5 countries.
Wow, that's amazing. And there's a very key thing that you mentioned. You know, over the past few years, your price per kilowatt hour has dropped so tremendously. Of course, you know, what would you say in terms of Huawei, and in relation to that, how is it that we are able to help you to meet this low tariffs?
I think first and foremost is, if I were to talk about as we move forward, clearly people have started to understand the solar power plants far better. So in a sense that we know that within a country, how location of the power plant sort of plays a major role. So I would come to Huawei, but before I come to Huawei, what you asked was that how the tariffs have gone down. So typically no longer people just randomly put solar power plants at any place. They sort of look closely at irradiance, which they were using it before as well. But I think it is with far more scrutiny that which is the best place where a solar plant can be put up. Alongside, what has happened is that the project sizes have also gone bigger. Earlier, it used to be 10 megawatt, 15 megawatt, 25 megawatt. Now you have multiples of 250 megawatt. And when you have multiple of 250 megawatt, yes, there would be optimization of not only the capital cost, but the operating cost maximization also happens. Clearly, as we are moving forward, module technology has also changed. It used to be polycrystalline. Now clearly we are looking towards a market which is moving towards monocrystalline, bifacial, half cell. Lots of things are happening. Module efficiency is getting better and better. Coming back to inverters in specific, clearly, if you have to have a lower capex, if you have to put up multiple plants over multiple years, you need to have faster project construction times. And when you need to have faster project construction time, you need to have something which will reduce the civil work, and it is easier to install. So when we talk about string inverters, they are easier to install. You don't need to have a large building to house the central inverters, and clearly on the back of MMS you can clearly connect the string inverters. With respect to Huawei, what we've seen is that we've compared Huawei with other string inverters as well, and we find that the MPPT, maximum power point tracking efficiency, we found it to be better in Huawei as compared to others. Clearly, because of this MPPT, we are able to have, we are able to sort of optimize the yield of the plant, and in a sense that the yield optimization is better when we used Huawei inverters. Second part is clearly, as far as India is concerned, there are high temperatures at all the places, and we found performance curves of these inverters are good at high temperatures as compared to other benchmarks figures. So that was something we were impressed by. I've been told that although the harmonics is subject to 3% variation, our plants can still manage, but with Huawei, we were able to limit it to 1%. As a result, the grid compliance is better and the grid power quality is also better. And I think the lastly, as I've been told by my technical team, this current voltage curve, this IV curve typically is only given in the workshop testing, but in case of Huawei, at site also, it is possible for us to make these curves. And this is very important for us because then we'll be able to optimize our solar plants. So I think all of this combined together, along with good service support, prompted us, enabled us to go ahead with Huawei. Of course, now the proof of the pudding is in eating, but clearly our journey has been good so long. I hope once the inverters gets installed, we would have the same experience.
That's wonderful. Thank you so much. I do have one last question for you, which kind of picks off a little bit of what you had mentioned earlier regarding the grid code. From what we gathered from last year in the market in India, the government had launched a new grid code with more stringent requirements for solar PV plants. From the perspective of a plant owner, how has this impacted you in terms of the selection of inverters? And just to be a bit specific, as we know the inverters are what gives the capability to meet these grid requirements. So how has that evolved somewhat, or has that changed the methodology or the principles behind how you select the inverters?
Yes, of course. See, with respect to the grid compliance, while there would be, I would say that the grid compliance code would run into several hundred pages, but typically, with respect to the inverters, we had to evaluate and we had to make sure that there are some specifications with respect to LVRT conditions, with respect to reactive power compensation, and with respect to active power control. So I think when we are selecting a string inverter, typically we would be more focusing on these parameters and how these parameters meshes with the grid compliance. And on all of these three accounts, we found that when we were evaluating Huawei inverters, it came out tops for complying with the new grid requirements.
That's amazing. That's wonderful. And thank you so much, Mr. Sanjay, for sharing your insights and knowledge with us. So now I would like to go to our next panelist. And our next panelist would be Ms. Jen Tan. Hi, Jen.
Yeah.
Yes, okay.
Hi.
So, as a leader of the solar business in Sembcorp Industries, you have led the team and signed over 246 megawatt worth of solar projects in Singapore. First and foremost, I'd like to congratulate you on that wonderful achievement. And as most of them are rooftop projects, and Sembcorp's aim is to power up 1,500 buildings by solar energy this year. The O&M coordination, execution of so many distributed rooftops would be such a mammoth of a task, coupled with the manpower resources that are required in order to carry out this O&M operations, so to speak. So, what would be your take on this in relation to the technologies that are available?
Yeah, indeed, O&M at multiple sites can be a very difficult task because you're talking about 1,500 rooftop in a big city. So I think we have embarked on smart O&M, and probably that's the only way to go. We use data to do fault analysis, to monitor our plant performance, to react to alarms remotely, and this actually helps us to optimize our O&M costs and manning costs. Can also do predictive maintenance rather than just routine cleaning for the sake of cleaning. And on the corrective maintenance side, we also use the smart IV curve function that Huawei recently launched. And this has greatly helped us reduce the troubleshooting time. And of course, reduction of troubleshooting time actually improves generation because we can recover fast and we also spend less time. So all in all, it's not only about cost reduction of O&M, it's also improvement of the generation of the solar plant.
Wonderful. And in relation to you, as you mentioned, cost reduction, of course, if you could put a number to it or a figure to quantify what would be the savings, as a result of this particular tool, for the O&M perspective.
Yeah, I think one of the two areas that we're talking about cost reduction, right, with the heavy digitalization is really the man required to pull, crunch the data, as well as the response time and man required for the troubleshooting of the solar plant. So I would say about minimum 20% of O&M cost reduction is breakdowns and corrective maintenance.
No, perfect. I mean, again, I think that is definitely one of the key things that we with those solutions that is provided that we aim to address accordingly. And you mentioned something about digitalization, and we understand that the Singapore government recently or has always been encouraging enterprises to move into this area of digitalization. How do you think digitalization will help the PV industry apart from the O&M?
I guess it's all about productivity improvement. When you talk about digitization, it's actually the ease of getting data and what do you do with the data. The data can actually be telling you the plant is suffering. The data can tell you how you do your design in the future to take care of your future performance. The data can also provide some technology study, performance, power curve, and so on. So in addition to the cost of human capital, it actually adds value to engineering. That's what I think. Okay. So the other thing that the data can help is to see if the plant is installed properly. In the past, you used to have one man walking around to use his visual power to see, is the connection done properly.
Correct.
I think with this online tools, it can help to reduce installation errors. And last but not least, I think one important tool that this digital platform and data can help us is when you want to refinance your plans, you have got good data to actually show your potential investors and buyers how your plan is performing. That actually speaks for itself. You don't have to do much marketing to let investors come and invest into your plan.
That's very true. So would you consider artificial intelligence as part of this digitalization?
Yeah, definitely. I think it is really, really important because it can help to provide a standardized behavior. I mean, different people, different engineers have different understanding. So artificial intelligence, if you teach it properly, it can really kind of a replacement, so that you can troubleshoot, or you can predict in a much faster and much more standardized way. So you actually eliminate human error.
Very good. That is very true. And that is exactly what artificial intelligence should address to reduce the human error, of course. So lastly, if I may, we noticed that there are more and more floating PV projects as well in Singapore. And of course, Sembcorp is developing these projects. What are the challenges for these floating PV projects, and how do you forecast in order to solve these issues? Like, say, for example, whether you apply some AI technologies into floating PV projects.
Yeah, I think the challenge for floating, I mean, as you all know, we are actually currently constructing a 60 megawatt floating solar plant in a little island like Singapore, where the reservoir space is also limited. I mean, we don't have abundance of space. So the way we actually lay out the modules is also in a very optimum layout. So the hindsight of it is it makes it difficult to enter and go to the specific area. So if there is really a plant issue, going on the floats and stepping around to find the fault can be a very, very difficult task. So AI, through imaging through drone, the IV curve tracing, or any kind of AI technology that is coming online. In fact, we are even considering GPS trackers. If there is a buoyancy that causes a float to fall apart, these kind of things can actually help us to nail down exactly where is the issue and let us troubleshoot it. So not only it improves productivity, it helps us to recover the plant, it is also much safer for our employees that is going on site for the troubleshooting. So they go to an area where it's spotted, and you don't have to loiter around the sea and risk falling off.
Yes, definitely. So in the interest of time, thank you so much, Jen, for your sharing. And now I'll turn my attention over to Mr. Kanin. Mr. Kanin is the Asian Development Bank and International Finance Corporation has awarded SunTrace and its partners to be the technical and commercial advisor for many big PV projects. Could you please provide some advices from the financial analysis and financial model aspect to our audience today?
I would gladly do so. So financing, of course, is key to competitiveness of a solar power plant. Long tenors, high debt share or leverage at low interest rates are essential to keep the energy tariff low. Yes. The longer the financing horizon, the more power the plant can produce, therefore the lower cost of energy. Favorable financing terms is only available when the entire structure of the project is robust and also bankable. And bankable in this case for non-recourse project finance, that each risk in the project is hence covered by the party that can best manage the risk. So EPC will cover the construction risk, O&M will cover the operation risk, for example. ADB and other development finance the projects in a way that these risks allocation is robust and well addressed. For them, it is very important to address not only the technical risks as well at the very early stage of the projects, so that the lower tariff can be obtained. For example, the ADB 60 megawatt project in Cambodia that we have advised, it has the lowest tariff in Southeast Asia at 3.87 US cent per kilowatt hour. Amazing. So we help them identify these fatal flaws at the early stage of the project. With respect to the solar resource, we set up a solar measurement station there, site suit, and last but not least is the environmental and social impact assessment. And at the beginning of the project development, coming back into the financing part, so the owners should conduct a cost benefit and financial analysis at a very high level. Does the project meet the certain minimum investment criteria? So return on equity, payback period, and these criteria and assumption are very country specific. And so a good understanding of that's why having a strong and good local partner is often seen in these cases. So after that, doing the concept development and site identification, support mechanisms such as tax exemptions and with import duties should also be assessed. And as the project progress into the development phase, with a complete funding strategy, including the CapEx and OpEx estimation, should then be conducted.
Okay, very, 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 very informative. I also like to, you mentioned something, and if I could just cap on that, is that you mentioned about CapEx and OpEx. Now, what would you say would be the consideration in terms of these two aspects, in terms of its importance, in terms of its weightage in your assessment?
The weight, of course, I think CapEx is of the utmost importance here, but nevertheless, you cannot neglect the OpEx as well. So in this case, for the CapEx, what we do at SunTrace is we do a techno-economic optimization, where we combine, optimize the design, not only technically, but also financially. So it goes hand in hand with our financial expert and also technical expert, so that you can find and optimize solutions. And for the Development Finance Institute, what we usually do is we set up a minimum functional specification, and then we allow the developers to be creative and find the best solutions and suggest it to us. Yeah. But CapEx is of importance. Yeah.
Okay. Would you say though, then based on that statement, of course, that CapEx is the main importance, that OpEx would also be sometimes an often overlooked item? And in your experience, have you experienced that before, in which the OpEx was what brought down the overall projections in terms of financing and so on and so forth?
Yeah, so allow me to give an example. So this is for a project in Namibia for a cement factory. So, it's the first CNI project of Africa. And basically the soiling rate there is insane. So it's a lot of dust, you have to measure the wind direction. And then for this, the screening routines has to be readjusted. And for that, we develop soiling measurement, along with our solar measurement solutions. So this is just one of the examples of how can you address the OpEx already at the early development stage as well. And also for the floating PV, I think for some projects, there are also unexpected risks like bird droppings, for example, that need to be assessed, and also the water quality and that has to be taken into account. Yeah.
Very good, very good. I think also in regards to SunTrace as being one of the 8 firms in the World Bank roster to provide these solar measurement services, could you explain the importance of solar measurement that you've mentioned earlier also?
Sure, most definitely. So the solar resource account for a decisive share of uncertainty when determining on the return of investment for a large-scale PV power plant. Mr. Sanjay also had mentioned a little bit about solar array earlier, so I'm very happy. But this certainty is not unavoidably given by the act of nature, but it can be actively reduced. The necessary degree of accuracy of your solar data can be adapted according to the project progress, maturity, and of course the budget. Yeah. Based on our experience, it is suggests that utility-sized solar power plant should be optimized using the meteorological data of the highest possible accuracy, preferably with on-site measurements if time constraints allow for it, of course. The data should not only include the GHI or the global horizontal irradiance, but also variables, in particular the DNI, direct normal irradiance, soiling rates, as already briefly touched earlier, and also the temperature. And double checks with different sources are essential. Yeah. So for some of our solar resource assessment for satellite, we use 8 data sets, for example, to make sure that this risk is reduced. The possible range of deviations and economic key figures is otherwise too large, and it may lead to the loss or unfavorable financing conditions, in particular at this moment in a competitive market environment. Compared to the risk reduction and also the impact on the economic key figures, investment in the on-site solar measurements are small, as we believe, and it should be considered for any utility scale solar power plants, which is usually the case for IFC and ADB as well. The first thing that we do for their projects is we set up a solar measurement station there.
Very good. That is definitely very important to understand and to know what are the key measurements that are required in order to do these assessments, of course. So as the head of the business development at SunTrace and Dornier Group for Southeast Asia region, you have many years of professional experience in Europe and Asia. How do you think AI technology would be helpful in grid supporting by smart grid connection algorithms?
Okay, so AI, artificial intelligence, intelligent machine that can change their own behavior without explicitly reprogramming through the collection and analysis of big data. For grid applications, which we believe will only become more complex as the deployment of renewable energy increases and the prosumer models are more widely adopted, I would definitely play a vital role in maintaining the grid stability and also reliability. So according to the report from ARENA, AI can ensure that grid operates at optimal condition and can optimize also the energy consumption of consumers. In Europe, AI is being used already to increase the capacity of power grid and to reduce the need for new lines by better understanding and better predicting the weather conditions. By automatically detecting the disturbance, AI can also improve the reliability and also the safety in power system. It can also enable the automated data processing in real time and also detect a case of emergency or appliance failures. Similarly, I think Jen has already touched on this a little bit. Predictive maintenance is also fairly well established by now. Machine learning algorithms can be used to identify components which are expected to fail soon, and these can be queued for maintenance. And other than the grid applications, AI can also be used for generation forecasts, demand forecasts, and also demand side management. Algorithms exist to predict this cloud covers, wind speed, and so on, which can be useful in producing a power output estimate, not only for solar, but also for wind parks. However, in order for AI to be effectively implemented for the power sector, availability and also the quality of the data, and last but not least, cybersecurity are of utmost importance.
Understood. So as you briefly touched earlier, with the levelized cost of electricity constantly going down, what would you say are the key features or factors that or caveats that we need to look out in doing these assessments?
Understood. Please don't get bored of me yet. But,
no, not at all.
The key to get the lower energy costs, in our opinion, are following: solar resource. I'll say it again. So the solar resource is a field for PV plants. The value of precise resource is key to leverage this solar economics. The more precisely you know the irradiation, the more precisely you know the energy yield, and then it's a key to your cash flow. The higher, the safer the cash flow, the better the financing term. So if you do not measure, and the bank and investor can take heavy discount on your energy you estimate and reducing the value of your project upfront. So based on our experience, in a large scale, let's say 100 megawatts, the reduction of uncertainty by solar measurement can reach a net present value in the dimensions of million US dollars. And for the CapEx, if you don't already have an in-house technical team, a seasoned technical advisor can also help get your construction price down. Perhaps this is one of the strongest lever that you can influence. So at SunTrace, we keep a close eye on upcoming technologies with respect to PV modules, including bifacial PV. We also measure albedo. Inverters, the string inverters, as already mentioned, trackers, and we also explore on the battery and energy storage system. Strong collaboration with manufacturers also help us in getting real-time equipment costs. And also we have further in-house price prediction models to help us identify a technical and also economically optimized system. We update the price forecast semi-annually to get a realistic picture. And since in the last 10 years, the cost of solar have gone down by 80% according to ARENA, it is very important to keep track of these prices. Last but not least, for the financing side, briefly mentioned already, low interest rate and long-term tenors are essential.
Perfect. Thank you so much, Mr. Kanin. I think that would be all the time that we have today. So once again, I'd like to thank Mr. Sanjay, Jen, and Mr. Kanin for joining us here today and really giving us such wonderful insights and knowledge that you have gained throughout the years in this solar PV industry. So once again, also if our audience have any further questions and so on and so forth, we'll be more than happy to take them and collate them and get the further responses accordingly. So with that, I would conclude this session and thank you for joining us once more and have a wonderful day.
So thank you, Ms. Tan, Mr. Agowal, Mr. Kanin Sirapa Asha for your sharing. So our final giveaway today, Huawei Letter P40 Pro, is about to start, and this time there will be 2 lucky winners. So please keep your eye on the screen and wait for your name. And congratulations to 2 lucky winners as usual. One of our team will be in touch with you shortly. Ladies and gentlemen, with insight from leading expert in PV industry, the key to the future of renewable is artificial intelligence. AI is playing an essential role in driving digital transformation in solar energy. Huawei's mission is to bring digital to everyone, home and organization, for a fully connected, intelligent world. As we come to the end of the year, we would like to invite you to share your feedback about today's summit. Your valuable opinion will help us improve further. Also, we would like to thank everyone who joined today's summit. Thank you to our invited guests who have shared valuable experience and insight. Follow us on our website and social media for further events like this. Once again, for those who join us today, thank you for your participation. Have a great day.